And you are of course most welcome. This is Project Euler problem number 6. The sum of the squares of the first 10 natural numbers is 385. The square of the sum of the first 10 natural numbers is 3025. Hence the difference between the sum of the squares of the first 10 natural numbers and the square of the sum is 2640. Find the difference between the sum of the squares of the first 100 natural numbers and the square of the sum. So this is a pretty straightforward brute force solution, but there's a beautiful elegant solution which I will show you as well. So sum of squares, set that to 0. Square of sum, set that to 0. So for I in range. So we're going from 1 up to 100, which means in Python we have to put 101 because Python's weird. What are we going to do next? Oh yeah, so sum of squares. Sum of squares, as the name suggests, is just 1 squared plus 2 squared plus 3 squared plus 4 squared, and all the way up to 100 squared. So we'll do I times 2. There we do. Right, square of sum. And this needs to be treated slightly differently because we're going to take the sum of all the numbers below 101, so 1, 2, 3, 4, 5, 6, and then square it. So we'll just add I there, and then down here we'll square it. So square of sum. There, that'll do. Now we just subtract one from the other, and it actually doesn't matter which way around you do it, you'll get the same difference. So print sum of squares minus square of sum, and that produces the wrong answer. What have I done? Did I square the wrong one? Square of sum plus equals I. Oh yeah, okay, so that should be plus equals. There, that's the correct answer. So there we are. Right, well, that was slightly embarrassing, but now let's look at the nice elegant solution. We can do all this. Basically you could do this on a calculator if you know the formulae. So the square of the sum is basically a triangular number. So the sum of natural numbers 1 plus 2 plus 3 plus 4 plus 5 and all that is a triangular number. So as a visual representation, think of the red balls in the triangle at the start of a game of snooker. So first row is just one ball, so you get a total of 1. Second row you have another 2 balls, giving you a total of 3. And third row you have 3 balls, giving you a total of 6. And of course fourth row you have a total of 10. So at n equals 4 the total equals 10, and there is a formula we can use to find n equals 100. So it's this formula here, and so it's n times n plus 1 over 2. So let's get rid of all this, we don't need any of this. Square of sum equals, and in fact I'm going to declare n as a separate variable because we're going to use it in the other formula as well. N equals 100. So it was n times n plus 1 divided by 2, and it's all of this squared, so it's the square of the 100th triangular number. So square that. That's that one. Now what about the sum of the squares? Now this is used in statistics all the time, and once again there is a nice neat formula for finding it. So it's this one here, n times n plus 1 times 2n plus 1 over 6. So nice and easy, n times n plus 1 equals, so it was n times n plus 1 times 2, oh, we're going to have to do that in double brackets, 2 times n plus 1, all of that in brackets because we're going to divide the whole thing over 6. Let's make it integer division. Let's make that integer division as well. Oh, what have I done? There. And now let's subtract one from the other. Print sum of squares minus square of sum, and we should get exactly the same answer with no looping whatsoever. There we are. So that is problem number 6, and I will see you next time for problem number 7.